is a this is a tutorial essentially to attempt to tie together all that you've learned so far about quadratic equations, how to find the roots and the vertex, and using the different methods. Before you go any further with this tutorial, make sure that you have printed off this page from the class web space. The link is up at the very top of your homework page. I'll kind of share over and see where you can get that from. So like if you go to the class web page, you can then go and print this. This is actually on our wiki page here. Okay, so stop the video, print that if you haven't already, and then start it up again when you've got a copy of this in front of you. Okay. All right. Okay, we're going to just look at each of these problems from the standpoint of using the different methods that you've been given. In each case, we're looking for the roots and the vertex. So the first function we're given is y equals x squared plus 2x minus 24. That should be right up at the top of your page. And I want both roots and the vertex. Okay. Now, if I just wanted the vertex, I might complete the square. Okay. But as you're going to find that if I want roots, sometimes it's just as easy to get the roots first and then pull the vertex out of the line of symmetry that you get from your roots. Okay. So by far the most efficient way to get roots is to factor, if you can. Okay. Now remember, going back to chapter 9, that when we do this little factoring tool, the top of the x here, make this a little clearer, the top of the x is a times c. The bottom of the x is going to be the b term. And of course, the a is going to be 1 if I don't have anything in front of this. 1 times x squared is x squared. So in this case, my a is 1, my b is 2, and my c is negative 24. So a times c is going to give me negative 24. B is 2. What two terms are going to multiply to negative 24 but give me a net result of 2? Well, I think of 6 times 4, because between the two of those, if one of them is negative, that's going to leave me a 2, but they will also give me negative 24. In this case, the 4 has to be negative for me to be left with a positive 2. Now, I can go ahead and then show the factored form. Y equals x plus 6 times x minus 4. This is the factored form of this function. But I'm really already doing more work than I need to, because to find the roots, what I'm doing is I'm setting this equal to 0. When I set this equal to 0, and I've got something that's without a 1 in front of that x squared, these numbers here are just going to be the negative versions of my roots, because I have to insert the negative version to zero these out. My zero product property says that either this or this has to be 0. So to zero that out, I have to put in a negative 6 or a 4. Those are my roots. I don't even need to do this. Okay? So my roots are done. For my vertex, I could start from scratch and complete the square, but I don't really have to do that. I could do my negative b over 2a, but I don't even really need to do that either because I have my line of symmetry when I have my roots. The line of symmetry runs right down the center of those. Between negative 6 and positive 4, I'm going to find negative 1. That's my line of symmetry. Negative 1 is 5 away from 4, 5 away from negative 6. If that's my line of symmetry, that's the x-coordinate of my vertex. All I have to do is plug that into here to get my y. So I'm going to say y equals 1 squared, 1, plus 2 times negative 1 gives me negative 2, minus 24, y equals what? Negative 25. So my vertex is negative 1, negative 25. Okay. I actually had already done it there. And my roots are these guys. Okay. I'm going to take a screenshot of that. All right. There they go. So I'm going to be able to post these on the class website. The one last thing that, because you have these graphing calculators, you should be doing is doing a quick check. Okay. So if I enter in my function, x squared plus 2x minus 24, I want to check my window. If I've got a minus 24, then that means I got to get down to at least negative 24, right? So I'm just going to change my window here so it looks like I'm going to get the parabola on here, which I did something wrong. Yeah, that's what it is. Negative 10. I'm going to do positive 20. And I'm not sure what just happened there. But let's try that. There we go. It's not too bad. Okay. So if it's tracing the parabola, then I can plug in and check. If I plug in negative 1, I should get out negative 25, and I do. If I plug in negative 6, I should get out a y equals 0, and I do. If I plug in 4, should get y equals 0, and I do. I've checked all of my numbers. Okay. Let's do the next one. Okay. Number 2 on your sheet is y equals x squared minus 13 plus 42. I want roots and the vertex. And the whole point of chapter 9 was factoring, because if I can factor, that's an efficient way of getting both, actually. Okay? My A here is 1. My B is negative 13. My C is positive 42. So I'm going to put 42. A times C is 42. B term goes in the bottom. Pause the video if you need to for a moment. Figure out what would go here. This is factorable. You should have gotten negative 6 and negative 7. 6 times 7 is 42. So negative 6 times negative 7 will give me 42, and their sum is negative 13. I don't have a coefficient before x, so this is one of those that these are the negative versions of my roots. If I put x minus 6 times x minus 7 equal to 0, then what will zero those out? My roots are a 6 and a 7. Okay? And then, do I have to start out from the very beginning to get my vertex? Absolutely not. Okay, I can complete the square, but in this case, again, I've got my line of symmetry. My line of symmetry is right in between. I'm going to circle these as my roots, but the line of symmetry is going to be 6.5 or 13/2, right? One or the other, however you want to deal with it. I'm going to put 13/2. Okay, I just need to plug in to get my y value. Okay, I'm going to use my calculator for this one with 13 and 42 in there. So 13/2, I'm going to use 6.5, right? 6.5 squared minus, this should be an x, right? Somebody should have probably caught that a while back. 13 times 13/2. And I could have used 6.5 plus 42, and I get negative 0.25 or negative 1/4. Okay, that's my vertex. And again, I'm going to check that. X squared, let's see here, minus 13x plus 42. I've got a y-intercept of positive 42, so I need to make sure my window will handle that or it's not going to be happy. Let's see here. Do negative 20 and positive 50. That ought to do it. We'll see how that does. Yep, there we go. All right. And again, I'll check all my numbers. 13/2, we said that was 6.5, right? If I want to do decimals, I can use that. Okay. If I put in 6.5, I should get negative 0.25, and I do. If I put in 6, I should get y equals 0. I do. Put in 7, I should get y equals 0, and I do. Okay, so all my numbers check out. Take a screenshot of that. And go on to the next. I'm going to circle that vertex, actually. Right? Okay. Let's go on to the third one. Okay, the third problem, which has got a number 4 in front of it, but it is the third problem on the page. Y equals x squared plus 2x minus 4. Okay, roots and vertex. Okay, this one I can try to factor, okay, but I'm going to find out that it doesn't work. Negative 4 times 1, I've got a positive 2, okay. 1 times 4 will give me 4, or 2 times 2. Nothing will give me a 2. So factoring's unfortunately not an option for me. So now I have to go to a plan B. I have a couple methods I can use. I can complete the square. This is pretty simple enough. I think I might do that. If I complete the square, I can get my roots from completing the square. Okay, so let's just go to the vertex first. If I complete the square, I have x squared plus 2x. Half of 2 is 1. Square it plus 1. In order to get back to negative 4, I have to subtract 5. And I end up with, take that square root, I have a plus sign there. Make sure you know how to do this. I'll do it slower on the next one to make sure that you can follow along. Remember, the vertex pattern is minus plus, so my vertex is going to be the opposite. It's going to be negative 1, positive 5, right? When you know how to do this, it's pretty easy, Okay? If you don't know how to do it, then you're going to want to practice. Let's say positive 5, negative 5. There we go. All right. So that's the vertex. How do I get the roots from that? Well, if I set this equal to 0, then I can move my 5 over to the other side. Okay? So I'm going to bring that over here. And I've got x plus 1 squared is going to equal positive 5. Whenever I move something to the other side of the equal sign, I just change the sign. Take the square root of both sides. The square root's going to undo the square. And I'm going to get plus or minus the square root of 5. That's where that plus or minus the square root of in the quadratic formula comes from. Then I subtract 1 from both sides, and I'm going to get x equals negative 1. Okay, that's my vertex. That's what it should be. Negative 1, either plus the square root of 5 or negative 1 minus the square root of 5. We could do that plus or minus if we want. Those are our two roots. Okay, I can do a decimal approximation, but I'm just going to do what I've been doing all along here. I'm going to put the function in and check. X squared plus 2x minus 4. Okay. This looks like it might fit in a nice normal window, so I'm going to do that, and it does. I'm going to hit trace so I can get my numbers. Okay, if my vertex is negative 1, 5, then if I put in negative 1, I should get negative 5, right? And it is. Sorry, I keep saying 5 instead of negative 5, but it's where it's supposed to be. If my line of symmetry is negative 1, and I'm just adding or subtracting my square root of 5, then I can actually, believe it or not, I can actually put this in this format. If x is negative 1 plus the square root of 5, it'll actually take that, then I should end up with y equals 0. And guess what I do? And I can check the other root, but by now I know this is all correct, right? Okay. So I'm going to take another screenshot of that. There we go. That's the next. And we're booking. All right. So on this one, just to recap, because x did not have a coefficient, we decided to use the completing the square method, and then we just used the vertex form to find the roots. Okay. Let's go on to the next one. This one I really would like you, now that we've done this much, have your pause button handy and pause the video. See if you can do this on your own. Again, it's one thing to watch me do it. It's another one to try to do it yourself, right? So let's do the fourth one, which is a number 6 on yours. I've chosen only certain problems. This one is not going to be just an x squared. Okay, so because of this, I'm going to go ahead and write my a is going to equal 8, my b equals negative 4, my c equals 1. Okay, and for this one, you don't want to, just because there's an 8 there, be afraid to at least try to factor, right? Okay, 8 times 1, okay, b is negative 4. Are there 2 factors of 8 that will give me a negative 4? Okay, so I've got 1 times 8, that won't do it. 2 times 4, that won't do it. There's really no other way to get 8, is there? So factoring is not going to be possible. Okay, that also tells us we're probably not going to get integer answers. So we're still going to be needing the roots and the vertex. But for this one, it looks like we might want to start with maybe the axis of symmetry, because obviously completing the square with this is not going to make a whole lot of sense. So the axis of symmetry is going to start with that negative b over 2a. Negative b is going to be positive 4. 2a is going to be 16, right? Therefore, it's 1/4. That's my x. Then I just start plugging in, okay? My y equals 8 times 1/4 squared, I can actually write as 1/16, minus 4 times 1/4. Well, 4 times a fourth is just 1, right? And then I've got plus 1. So these guys actually, so this turned out to be pretty easy. Minus 1 plus 1, 8 times 1/16. The 8 and the 16 simplify to 1/2, right? Looks like y is 1/2. Okay, so that actually wasn't very scary. So the vertex is 1/4, comma, 1/2. Okay. All right. If I want to know my roots, okay, then I can basically use the other piece of this. I've already got for the quadratic formula, I've already got my negative b over 2a is 1/4. Plus or minus my line of symmetry. So now I'm going to use the square root of, right, b squared is going to be 16 minus 4ac. 4 times 8. Ooh, I think we're going to end up with no roots on this one, right? If I'm not mistaken. Because the only negative term is here. Yeah, it's 4. I don't even really want to do much work, any more work, because I'm going to end up with a negative in my discriminant. 4 times 8 is 32. So we're going to end up with that. So I'm going to stop right there, and then I'm going to confirm that I do have no roots by putting this in my graphing calculator. 8x squared minus 4x plus 1. And that window still may not be large enough. We'll see. Look and see. Yeah. Well, if you can see on I can zoom in here. And now you can see a little bit better that obviously it is not going to cross the x-axis. I have no roots. It's floating. Okay. So, no roots. Okay, that's that one. Take another screenshot. That's that one. Okay, let's keep going. So far, I don't know that I think maybe I've done a completion of the square. I'm just kind of talking through little by little what's your thought process? What tool am I going to use for the right job? Okay, if you turn that page I had you print to the next one, your function should be y is equal to 3x squared plus 12x minus 3. Okay. And this one, if I factor out that 3, I can possibly make my life easier, especially when it comes to the roots. Okay. But sometimes factoring out can actually make the vertex more difficult if you're trying to complete the square. So I think for purposes of what I'm doing, I'm going to just say my a equals 3, my b, well, you know what, for roots, yeah, I'm still going to do this. A equals 3, b equals 12, c equals negative 3. Okay. I'm just wondering, if I factor that 3 out, if I have a factorable form, that's going to be my easiest way to get my roots. So sorry to keep going back on you, but I am going to rewrite this as 3 times x squared plus 4x minus 1. But guess what? I don't have... I was thinking I might have a perfect square trinomial, but I can't get a -1 there. But let's just make sure I'm not thinking the wrong way. Well, 1 times, I need something, the only way to get a -1 would be -1 times 1. I can't get a 4 from that. So yeah, there's nothing I can do to factor. All right. So if I'm going to do that, I think I'm just going to go back to my original plan and just do my A equals 3, B equals 12, and C equals -3. And just use maybe the quadratic formula. That shouldn't be all that difficult for this one. Okay. So given that, I'm going to start with my negative b over 2a. Negative b is -12. 2a is 6. So it's going to be -2, right? That's my line of symmetry. Okay. That's kind of nice. And then to get the y term, I just plug the -2 in here. I get 3 times -2 squared is 4, plus 12 times -2. I could just rewrite that as -24. And then -3. So this becomes 12 minus 24 gives me -12. I should end up with -15. Can go and check that one if I want. Let's see here. Yep, that's correct. Okay. A little nicer for my camera work. That's going to give me my vertex. Okay. This is my y equals -15. Well, again, over here for the roots, I'm going to have my line. They're going to be the distance between my line of symmetry. So I'm going to be starting with that -2. That's my negative. That's my -b over 2a, right? Plus or minus the square root of, what's b squared? 12 squared is going to be 144 minus 4ac. 4 times 3 is 12. Or I could actually do 3 times -3 will be -9. 4 times -9 gives me -36. I'm going to end up with, and this is all over 2a, which is 6. So I get -2 plus or minus 144 plus 36 minus a minus is going to give me, what, 150, 180, right? The square root of 180 over 6. I'm looking for perfect squares. Well, I know I've got 9 in here, right? 180, that would be 9 times 20, and there's a 4 in there. So that's 36, right? So I've got a couple of, if I were to, I can factor here, 180, if I divide that by 36, it's 5. Okay, so 180, 36 is 6 squared. So if 180 is 36 times 5, I can say that it's -2 plus or minus 6 over 6 over 6 is going to cancel. Okay, so I'm going to go ahead and write it out though. 6 over 6 times the square root of 5. These guys cancel. It's going to be -2 plus or minus the square root of 5. Okay. So I'm going to write that a little bit. So -2 plus the square root of 5 or -2 minus the square root of 5. That's going to be my roots. Okay. And if you, of course, plug that into your calculator, if I maybe do this one more time, 3x squared plus 12x minus 3. See if my window is big enough to handle that. Not even close, is it? Zoom out. See if that did it. Pretty close. I still need to go lower down on my y min, huh? I'm going to go down to, say, -20. Try that. There you go. So I can see the whole parabola. Then I can put in my -2. I get out -15. Should have known, go a little lower than that. And if I wanted to do -2 plus the square root of 5, I can check that. And I get 0. I can check my other one. So my work all checks here. There we go. Take a picture of that one. We got 2 to go. Okay. Y equals x squared minus 10x plus 25. Why did I throw that on there? Well, I think it's real easy to not notice something that's actually much simpler to do than to maybe pull out like a set of power tool like the quadratic formula. Obviously, we've got a perfect square trinomial here. This is a perfect square. That's a perfect square. If I take the square roots of both of these, right? The square root of x squared is x. The square root of 25 is 5, or plus or minus. If I double those, I do get the -10. So I did throw this on here to remind you that this does factor. I'm still looking for roots, though, and the vertex. Okay? So in this case, for the vertex, this is super easy to put in a vertex form because it's already a perfect square. I can say that it's y equals square root is, right? It's square root of 25 is 5. I've got a negative sign in here. So this is it. And it's plus 0. So my vertex has to be 5, 0. That's simple. Okay? And my roots, okay, if you remember, you should know by now that if I have a perfect square trinomial, I'm only going to have one root. That's because I'm going to set it equal to 0. And the only way to get 0 is if this is 0, and the only way for this to be 0 is for x to be 5. If x is 5, y is 0, and now you notice that the vertex and the roots are the same. If I put this on my calculator, what I should find is that parabola should just be touching the x-axis in one place. X squared minus 10x plus 25. And it should be right at the 5, right? So if I plug in 5, I should get 0, and I do. Okay? Okay, the last one, I'm going to go really slow. And I want you to do as many of the steps as you possibly can on your own. Okay. Y equals 4x squared minus 5x plus 11. Okay. I could try to factor. You never know, right? If I want roots, factoring is a real nice way to do it. If I do that, I'm going to have my A times my C. 4 times 11 is 44. The middle term is -5. Why don't you take a moment, stop the video, tell me if you're going to be able to factor this one or not. Okay, you should have found that you're not going to be able to factor this one. Okay, to get 44, I can do 11 times 4, or I can do 2 times 22. I don't have a whole lot of different factors involved here. It's 2 times 2 times 11. I can't get a -5 out of that one. So I'm going to be going over, I'm not going to complete the square with that 4 there. Okay, I can't factor out the 4. So I think I'm going to end up doing the axis of symmetry method for the vertex, and then I'm going to use probably either the quadratic formula or that line of symmetry. If it's easy, I'm going to use that to get the roots. But I'll start with that vertex. So it's a little easier if I keep track of my A, my B, and my C in an organized way. Okay. I'm going to use -b over 2a. So what's my x-coordinate going to be of my vertex? Okay, so I get 5/8 or 0.625. And then in order to get the y, what do I do next? Pause and do this yourself. And then come back and check the answer. I get a decimal answer for my y of 9.4375, which I will also express as a fraction, a nice, lovely number of 151/16. But I also know that because 16 is twice 8, that makes me feel really good about that answer. And I'm going to go check it, obviously. Okay, I'm actually going to write this way down here as the vertex. Okay. But I've got my decimal answers to help me check that. Okay. Now what do? How can I get my roots if I'm going in this direction and it has to do with this? Stop a moment and think about it. If I've already gone in the direction of using the axis of symmetry for the vertex, I might as well use the quadratic formula to get my roots. Just is the only thing that makes sense usually. So I've already got my -b over 2a. That's 5/8, right? Done that part already. Plus or minus. Got this parabola. This is the line of symmetry. The roots are going to be at equal distance on both sides. Why? That's why the plus or the minus. square root of b squared, which is that. That's going to be 25 minus 4a. 4 times 4 is 16 times 11. Oh, guess what? I already know I've got a negative number, right? My discriminant is negative. Therefore, no roots. Right? Okay, I'm done. And then I can put that in there and just double check it. Okay, and if I trace that, I know my vertex is actually, let's see, my vertex is around 1 and 9. So I do need to make sure that my y maximum isn't enough. There we go. That's why I didn't see it. Yeah, it's floating up above there, right? Okay. And so if I plug in my 0.625, I should get my 9.4375, and I do. And of course, I can already see I don't have any roots. All right. So I'm going to take a shot of that. Okay. And that's what I have on the sheet of paper. I'm actually going to just throw one last problem on here, though, and that's related to what we did in class, where a lot of you had forgotten how to do problems that you could factor, as we said, like the hard ones, as they used to be called. They're not really all that hard. This was from page 24. So let's run through, I'm going to run through one last problem like this, okay? And so we're going to do one that actually has solutions. I'm going to take, let's see here. Why not do number 9 on that page? Okay. It's written out as 4x plus 4 equals 3x squared. 4x plus 4 equals 3x squared. And as we noticed in class, if I want everything on the other side, I just move the negative over. Okay. So that's going to be minus 4x, because I have to subtract 4x to get rid of it, right? And minus a 4, because I have to subtract a 4 to get rid of that. Okay, so that's putting this back into standard form, which will also make it easy for me to set it equal to 0. And so I could just pull out the quadratic formula, but again, I'm looking for roots and the vertex, and it isn't. If you haven't forgotten how to do it, factoring is a good way to do it, okay? So my A times my C, my A is 3 times negative 4 gives me negative 12, A times C. Negative 4 down here, and if I multiply negative 6 times 2, I get negative 12. If I add them together, I get that, okay? But I can't just circle those things and put the negatives down for my roots because I have a 3 in front of here, right? So this was one that in order to factor it correctly, we had to do the little factoring box. I had 3x squared, negative 4, right? And then I take these two factors and stick them in here, negative 6x and 2x. So these two terms go in the corners. These two go in the other corners, right? And then I just factor it. It doesn't matter what order I go in, but I just factor out. Well, between the 4 and the 2, I can only factor out a 2. okay, between 4 and 2x. And I leave the signs last, okay? I'm going to need a negative sign somewhere here. But I'll make sure that the negative signs work out. If I go up again, I've got a 3 and an x in both of these terms. So I've got 3x, okay? Going sideways between 3x squared and 2x, I've only got an x. Between negative 6x and negative 4, I have negative 2. And that actually is going to give me my sign, my negative 4. So I know that that's going to be a plus, okay? So for my roots, I now know that I've got 3x plus 2 equals 0, or x minus 2 equals 0, right? Which of course means that one of my roots is going to be 2, okay? This one, if I subtract the 2 over, I get 3x equals negative 2. Therefore, my roots are going to be x equals negative 2/3 or x equals 2. Okay? And yes, I can get my line of symmetry from that by doing the whole little thing of what's in between, but now it's starting to get ugly with fractions. So I'm going to go back to my negative b over 2a. Trusty little tool there for my vertex, right? Negative b, positive 4. 2a is 6, okay? And that's going to give me positive 2/3. And then I just have to ask myself, does positive 2/3 fit in between here? And actually 2/3, 2 in terms of thirds is actually 6/3, right? So that would actually fit 6/3, negative 2 to 6/3, 2/3 would fit right in the middle. So that looks right. It is right. Okay. Then I plug that in to get my y. 3 times 2/3 squared minus 4 times 2/3 minus 4, running out of room there, but getting it. Okay. And this was actually not on the sheet because you weren't asked to find the vertex, but you can see it's not hard. This is a really powerful tool to find the vertex. Find it, then plug it in, okay? It's not that difficult, especially with these calculators. So 3 times 2 divided by 3, 2/3 squared minus 4 times 2/3. I always use fractions for thirds because I could do my 0.6666 or whatever, but it's not accurate because it's they're thirds, obviously. Minus 4, okay? So I end up with negative 18.666, which means 2/3, right? If I'm really lazy and I want to just see the fraction, it'll give it to me. That's negative 56/3, right? Okay, so my vertex is 2/3, comma, negative 56/3. Okay, if I did my math right, and I'm going to double check it. Okay, 3x squared minus 4x minus 4. Trace that. Pretty confident in my answer. Okay, and my roots at negative 2 divided by 3 should give me 0. Yep, it does. 2 should give me 0, right? The vertex should give me these coordinates here. 2 divided by 3 should give me, and it doesn't. So what did I do wrong here? I did something wrong on the vertex. So I can go back here. This is why I check my answers. Okay. I can go back to see if I made a mistake here. I had 3 times. I did. I made a mistake. I don't know if you can see on my calculator. So this is why you check. All right. So I'm actually going to go back and do my math. I missed a parenthesis. Okay. So I'm going to go back here and I'm going to do 3 times 2/3 squared. That's where I missed a parenthesis. Okay. Minus 4 times 2 divided by 3 minus 4. And I get the right answer. It's supposed to be a little easier on my whiteboard. This is going to be negative 5.33, which in fraction terms is negative 16/3. And that does match the answer on my parabola. Okay, that's why you check on your calculators. Okay, that is a full day's worth of homework. It's 8 problems, but that's all I want you to work on. I really want you to focus on getting your understanding down of all the different ways that I've worked these. Make sure that you can understand these solutions. Make sure that you can work them yourself. If you end up reprinting the thing a second time and just work them all yourself, that's what you need to do. You guys are all at this point where you can fully understand when I work things on the board and you're understanding the techniques, but you need to be able to pull this out of your own head and produce it. Like I said, as if you're on the bicycle pedaling yourself and I'm not pushing you any longer. Okay, so I'll give you a little bit more instructions in the homework, but hopefully that's going to help you out. I'm going to take another screenshot and we'll be posting these on the website. All right, see you guys later.